Two people start taking creatine on the same Monday morning. The first is 28 years old, trains 5 days a week, and is taking creatine specifically for muscle performance and strength gains. The second is 64 years old, walks for exercise 3 times a week, and is taking creatine on the recommendation of a physician who read the recent literature on brain health. 4 weeks later, both of them have higher phosphocreatine stores. Both are experiencing measurable changes, but the research suggests that the magnitude of benefit for one of them, for a specific outcome that has nothing to do with muscle, may be significantly larger than for the other. Which one gets more from daily creatine depends entirely on what you measure, and the answer for the second person is something that most of the fitness world never talks about when the subject of creatine comes up. Subscribe now because the next video covers the 3 most common creatine mistakes that reduce how much of the supplement actually reaches the tissues that need it, and how to correct all 3 without changing your dose. Think of your body's energy system as a hybrid vehicle. The primary fuel is adenosine triphosphate, ATP. It is the direct currency of every muscular contraction, every neural firing, every enzymatic reaction in every cell. The problem with ATP is that your cells store very little of it at any given moment, enough for a few seconds of intense effort. After that, the engine stalls unless it can be rapidly refueled. Phosphocreatine is the emergency battery. When ATP is depleted during intense activity, phosphocreatine donates its phosphate group to resynthesized adenosine diphosphate, converting it back into usable ATP within milliseconds. This is not a slow process. It is the fastest energy resynthesis pathway in the body, operating at a speed that no other system can match. This battery exists in the muscles. It also exists in the brain, and daily creatine supplementation charges both batteries, but not at the same speed, not to the same extent in every person, and not with the same timeline of effect. Here is what happens week by week. Days 1 through 7, the muscle loading phase. When you take 3 to 5 grams of creatine monohydrate daily, it enters the bloodstream and is transported into skeletal muscle cells by a specific transporter protein called SLC6A8. Inside the muscle, it is converted to phosphocreatine and stored. The total phosphocreatine capacity of skeletal muscle is roughly enough to sustain maximal effort for 6 to 10 seconds before it is depleted and needs time to resynthesize. Daily supplementation at 3 to 5 grams begins increasing the phosphocreatine pool in muscle within the first week. An optional loading phase, 20 grams per day for 5 to 7 days divided into 4 doses, can accelerate this process, reaching near saturation within a week. Without loading, full muscle saturation takes approximately 3 to 4 weeks. The end result is the same, only the timeline differs. What you feel in week 1 is largely nothing. The battery is being charged. The vehicle is not yet running differently because the driving conditions have not yet demanded the full capacity of the expanded battery. But here is the detail almost nobody mentions about week 1. Some water follows creatine into the muscle cells. This is intracellular water, inside the muscle fibers, not under the skin. The body weight may increase by 1 to 2 kilograms in the first week. This is not fat. It is not subcutaneous bloating. It is the fluid that accompanies creatine into the cells where it will be stored. Most people who stop creatine in week 1 because of the scale have abandoned the supplement at the exact moment the battery was being installed. Weeks 2 through 4, the performance change. A systematic review and meta-analysis published in the journal Nutrients in 2024 by Wang and colleagues analyzed 23 randomized controlled trials on creatine and resistance training in adults under 50. The finding was precise. Creatine combined with resistance training increased upper body strength by an average of 4.4 kilograms compared to placebo, and lower body strength by 11.35 kilograms. Both results were statistically significant, with a p-value below 0.001. These numbers represent the compound effect of more phosphocreatine available for resynthesis during every set, every sprint, every explosive effort. More ATP available per second means more work output per session. More work output per session means more mechanical stimulus for muscle protein synthesis. More stimulus over weeks and months means more muscle. The mechanism is not anabolic in the hormonal sense. Creatine does not raise testosterone in any consistent and meaningful way. The research on this is mixed, and the effect sizes where present are small. What creatine does is allow the muscle to train harder, longer, and more frequently by recovering the energy system faster between efforts. The strength gains come from the training quality. The creatine enables the training quality. And here is where it gets more surprising. The two 28-year-old and 64-year-old are tracking similarly on the strength metric at week 4 if both are doing resistance training consistently. The age gap in response to creatine for muscle performance is smaller than most people assume. Weeks 4 through 6, the brain. This is the part that most creatine content never reaches. The brain contains its own creatine transporter. Brain creatine stores are independent of muscle creatine stores and respond to supplementation on a different timeline. Full saturation of brain phosphocreatine pools from oral supplementation at 3 to 5 grams per day takes approximately 4 to 6 weeks, longer than muscle saturation. This is why studies measuring cognitive effects of creatine at 2 weeks often show nothing. The battery in the navigation computer has not finished charging yet. Prokopides and colleagues published a systematic review and meta-analysis in Nutrition Reviews in 2023, analyzing 10 randomized controlled trials on creatine and memory. The overall effect was modest but measurable. When the researchers separated results by age group, the picture became significantly more interesting. In adults aged 66 to 76, the memory improvement showed an effect size of 0.88, a magnitude classified as large by the Cohen statistical standard. In younger adults, the same analysis showed no significant effect. This is the answer to the opening comparison. For pure cognitive memory benefit, the 64-year-old has more to gain from daily creatine than the 28-year-old, not because creatine works differently in older brains, but because older brains are operating with lower baseline creatine stores and have more room for improvement when supplementation brings those stores up. And a study published in Scientific Reports by Nature in 2024 found something equally striking outside the context of aging. A single high dose of creatine, measuring 0.35 grams per kilogram of body weight, restored cognitive performance in healthy adults during 21 hours of sleep deprivation. The brain's phosphocreatine pool, when depleted by extended cognitive effort and lack of sleep, responds measurably to creatine availability. The navigation computer runs better when the battery is charged. Long-term, the kidney question. Almost everyone who takes creatine for more than a few weeks encounters this at some point. A blood test comes back showing elevated creatinine, the waste product filtered by the kidneys. The doctor flags it. The person stops taking creatine, and they stop based on a fundamental misread of what the lab result means. Creatinine is a breakdown product of creatine metabolism. When you take more creatine, your body produces more creatinine as it processes that creatine. This is a direct and expected metabolic relationship. The presence of elevated serum creatinine is used as a marker of kidney function because, in the absence of creatine supplementation, higher creatinine usually indicates that the kidneys are not filtering efficiently. The distinction is critical. Creatine supplementation raises creatinine without impairing the kidney's actual filtration capacity. The International Society of Sports Nutrition Consensus Statement, published by Antonio and colleagues in 2021, reviewing the evidence across decades of research, confirmed that creatine supplementation shows no evidence of causing renal or hepatic toxicity in healthy individuals at recommended doses. The creatinine goes up. The kidneys remain fine. A person with existing kidney disease should speak to their doctor before taking creatine, not because creatine causes kidney damage, but because elevated creatinine in that context may mask changes in filtration that would otherwise be detected. For healthy adults, the concern is not supported by the literature. Before the protocol, nothing here replaces medical guidance. If you have kidney or liver disease, are pregnant, have a history of any condition affecting creatine metabolism, or take ongoing medication, speak with your doctor before supplementing. The mechanisms described here apply to creatine in healthy adults at standard doses. Creatine is a supplement, not a medication, and does not treat any specific condition. The practical protocol supported by the research is simpler than most people implement it. 3 to 5 grams of creatine monohydrate per day, every day. No cycling, no breaks, no loading phase required for most people unless a faster timeline to saturation is specifically needed. Taken at any time of day, the timing within a day does not meaningfully affect the outcome. Taken with food or without, absorption is not significantly different. Consistency across weeks and months is the only variable that determines whether the muscle and brain stores actually reach saturation. The hybrid vehicle with a fully charged battery does not drive differently in the first 5 minutes after charging. It drives differently in hour 3 when the reserve is still available, and the vehicle that never charged has already started making compromises. If this changed how you think about what creatine is actually doing across different time horizons, subscribe and leave a like. Tell me in the comments, how long have you been taking creatine, and did you know the brain effects take 4 to 6 weeks longer than the muscle effects to fully develop? Next video, the 3 mistakes that reduce how much creatine actually reaches your muscles and brain, and the specific fix for each one that requires no change in dose.